Hello everyone. Today we're going to learn about significant figures. All the digits in a record number serve one of two functions. Either they are a significant figure, a quote important digit that is related to the precision of the data that's being recorded. Traditionally it is all the known digits for the data point and one final estimated digit. If you're not a significant figure, you are acting as a placeholder. The purpose of these digits is only to mark the size or magnitude of the number in question. Think trailing zeros on a large number like 10,000 would be placeholders. So let's talk about which digits are significant. All digits that are the numbers 1 through 9 will be significant no matter what number they are present in. Zeros, on the other hand, are questionable. Either they're going to be significant or they will be placeholders. But the real question is, which are they? So let's look at a couple of rules to help us determine how a zero is behaving. Rule 1 we'll call the sandwich rule. Basically, if a zero is sandwiched between two other significant figures, it also becomes significant. For example, in the number 1001, the two zeros in the middle are sandwiched between the ones on either side. So therefore, those zeros must also be significant. So there are a total of 4 significant figures in the number 1001. Rule 2. You can mark zeros if you want to specify that they are significant. There are a couple of different ways you can mark zeros in order to mark them as significant. One common way is to include a decimal point with nothing after it. The other main way is to put a bar over the final significant zero. For example, if you say the number 1000, there's nothing to tell me that the zeros that follow the 1 are significant, so they're just simply placeholders in this case. However, if I say 1000 point, it's interesting that I specifically mentioned the decimal, and therefore that must be marking significance. Those 3 zeros are now significant, and therefore in the number 1000 point, there are 4 significant figures. Rule number 3, I like to call the right and right rule. Zeros that are both to the right of a decimal place and also to the right of a significant figure become significant. Basically, this covers what we would consider trailing zeros on numbers where there is a decimal involved. For example, in the number 1.50, there is a significant zero there at the end because it is both to the right of the decimal and a significant figure. In this case, you can say either the 1 or the 5 as the significant figure that it is to the right of. So therefore, 1.50 has 3 total significant figures. The number 0.05 does not have any significant zeros in it. The first zero is to the left of the decimal, and so it cannot fit this rule. And the second zero is to the right of the decimal, but there is no significant figure it is also to the right of, so it only fulfills one of the 2 requirements here. In the number 0.550, there is one significant zero, the second one. The first zero is to the left of the decimal and therefore does not follow this rule, but that second zero is both to the right of the decimal and also to the right of a significant figure. Either of the 5s count as the one there. So in the number 0.550, there are 3 total significant figures. So let's talk about placeholders. If a zero is not significant, that means that it's serving the place of a placeholder. There's 2 general situations where you can look for a placeholder. For large numbers, basically anything larger than 1, placeholders are trailing at the end. For example, we mentioned the number 1000 earlier. The number 1000, with no markings on it, has 3 placeholder zeros, which means it has no significant zeros in it. Therefore, the number 1000, again with no markings, has only one significant figure, the 1. For a small number, basically for a decimal number less than 1, the leading zeros are the placeholders. These make sure that when you read the number, you can tell that it is in fact a decimal and not something different. For example, in the number 0.0035, there are 3 placeholder zeros, the 0 before the decimal and the 2 that are immediately after it. Therefore, since they're acting as placeholders, they are not considered significant zeros. Therefore, that number only has 2 significant figures present. So let's take a moment to look at some examples and determine how many significant digits are present in the following. So take some time now on your own to make a guess at how many significant figures are present in the 6 values shown. Let's look at our answers. 54.78 has 4 sig figs because there are no zeros there, so we don't have to question any of the numbers there. They're all digits 1 through 9, so they all count. In the number 4.50, there are 3 total significant figures. That 0 follows our, quote, right and right rule. It is to the right of a decimal and right of a significant figure. Another way to think of this as it's a 0 that trails after a decimal. Why did I include the 0 there? I could just as easily say 4.5 and have the same value, but not the same significance and the same precision. So it was included, it is important, it is a significant figure. In the number 1205, we have a sandwich 0, and so there are 4 total significant figures. In the number 15.0, we again have a 0 that is after a decimal and to the right of a significant figure, and so there are 3 total significant figures. 0.54 has 2 significant figures because that leading 0 is not to the right of a decimal, nor is it to the right of a significant figure, and so it does not count. And in 0.05950, there are 4 significant figures. That should say 4. The 5, 9, and 5 obviously are going to be, and then there is 1 significant 0, the 0 trailing at the end of this decimal number. The 2 in the beginning are leading zeros on a small number, and therefore they're going to act as placeholders. So again, there are supposed to be 4 total significant figures there. Let's talk about what happens when we have to do math and have to round appropriately. The reason significant figures are important is they deal with your level of precision. Again, significant figures are the number of known numbers in your values in your data point plus 1 estimated digit. So for example, if you have markings for the tens and ones place, you can make a guess at the tenths, and then you would have 3 significant figures. The fewer significant figures you have, the less precise you are. The more you have, generally the more precise you are. So when you're doing math, your precision for your calculation becomes limited by your least precise data point. How this rule applies depends on the math operation involved. So let's look at our 2 main groups. For addition and subtraction, when dealing with addition and subtraction, you should round to the fewest number of decimal places present. So for example, if I add 15.0 plus 3.55, ordinarily without rounding, I would have 18.55, but I can only keep 1 decimal place. So that 0.55 rounds to 0.6. So the answer for 15.0 plus 3.55 is 18.6. For multiplication and division, you should round to the least number of significant figures present in the numbers that you are multiplying or dividing. This is the rule that we will more commonly use in this class, since most of our math operations involve multiplication or division, or both. So, for example, if we took 15.0 times 0.0035, the correct answer for this will be 0.053. 15.0 has 3 significant figures, while 0.00535 has only 2, which means our answer can also only have 2 significant figures present in it. There are a couple of other math operations we'll run into later in the year that will have their own significant figure rules, but we will deal with them when we get there. Good luck on your practice.